Hello friends, now in this video we will discuss the board's question which asked from 1996 to 2024. I will explain all the examples with very simple language. In board examination, weightage of definite integration is 6 marks. At the same time, I will give the link of exercise 4.1, 4.2 and miscellaneous exercise in the description box. I will explain all the examples in a very simple language. Now let us start. The first multiple choice question. First question, integral 0 to alpha 3x square dx is equals to 8. Then the value of alpha is. This question asked in March 15 examination. First option A is 0, B is minus 2, C is 2, D is plus or minus 2. Now we'll solve this example. Use here formula, that is integral x raised to n dx is equals to x raised to n plus 1 upon n plus 1 plus c, and the fundamental theorem of integral calculus, that is integral a to b f of x dx is equals to g of b minus g of a, where the integral of f of x is g of x. See this here. The solution. Integral 0 to alpha 3x square dx is equals to 8. What is the integral of x square? X cube upon 3. 3 is a constant, multiplicative constant. Now we substitute, that is x is replaced by alpha, 3 get cancelled. Then you will get here alpha cube minus 0 cube is equals to 8. Alpha cube is equals to 8. Therefore, alpha is equals to 2. Taking the cube root on both sides. And hence here option C is correct. Now next. If I is equals to integral minus pi by 2 to plus pi by 2 sin of x raised to 4 plus cos of x raised to 4 upon sin of x raised to 4 dx, then the value of I is, first option A is a 0, B is pi, C is pi by 2, D is pi by 4. Okay, now we'll evaluate this integration. Since the integral, the given function is a even function, therefore I is equals to 2 times 0 to pi by 2 sin of x raised to 4 upon sin of x raised to 4 plus cos of x raised to 4 of the property of the even integration. Now next, replace this x by pi by 2 minus x. Then with the help of the property, integral 0 to a f of x dx is equals to 0 to a f of a minus x. That is here we have replaced x by pi by 2 minus x. But what is the sign of pi by 2 minus x? Is a cos x, and cos of pi by 2 minus x. Here is a minus x, and that's it. I will write here. This is the minus sign. Okay. Cos of pi by 2 minus x is a sin of x, and here therefore our integral becomes I is equals to 2 times 0 to pi by 2 cos of x raised to 4 upon cos of x raised to 4 plus sin of x raised to 4 dx. This is the second one. Adding 1 and 2, both of them have the same denominator. Therefore, to the numerator you will have sin of x raised to 4 plus cos of x raised to 4 upon cos of x raised to 4 plus sin of x raised to 4. Numerator, denominator are both are same. Therefore, 2i is equals to I plus I. That is a 2i is equals to 2 integral 0 to pi by 2 1 dx. And what is the integral of 1? That is x. Again, the upper limit is pi by 2, lower limit is 0. If we substitute pi by 2 minus 0, then I is equals to pi by 2. And hence option C is correct here. Next, integral 4 to 9 1 upon root x dx. This question asked in July 16 examination. First option A is 1, B is a minus 2, C is 2, and D is a minus 1. Now we'll evaluate this integration with this formula. Okay. Now again, the theorem of the fundamental calculus. Integral 4 to 9 1 upon root x dx. Now the power of x is 1 upon 2. If we take to the numerator, it will become minus. That x raised to minus 1 upon 2 dx. What is the integral of x raised to n, that is n plus 1 upon n plus 1, minus 1 by 2 plus 1 means what? X raised to 1 upon 2 upon 1 upon 2. Multiply and reciprocal, here you will get here 2, that is a x raised to 1 upon 2 means what? Root x. Upper limit, lower limit. Substitute the values. Okay, here we have substituted. Root of 2 in bracket root of 9 minus root of 4. Root of 9 means 3, root of 4 is 2, 3 minus 2 is 1, 1 into 2 is a 2. And hence the option C is a correct here. Now next, if integral 0 to alpha 3x square plus 2x plus 1 dx is equals to 14, then alpha is equals to. This question asked in July 17 examination. First option A is 1, B is 2, C is minus 1, D is a minus 2. Now we evaluate this integration. What is the integral of 3x square? That is integral of 3x square is a 3x cube upon 3. 3 get cancelled, you will get here x cube. Next, 2x square. Integral of 2x square is a 2x square upon 2. Again 2 to get cancelled. Integral of 1 is x. Lower limit is 0. Upper limit is alpha. And that's equals to 14. Upper limit minus lower limit. Lower limit is 0. Therefore, we have the upper limit. Alpha cube plus alpha square plus alpha. And take this 14 to the left hand side. It will become minus. Now factorize this. Okay. Therefore, the factors are the alpha minus 2 and in second bracket alpha square plus 3 alpha plus 7, that's equals to 0. Now the factors of that is the root of this alpha square 3 alpha plus 7 does not have the real roots and hence that is the alpha is equals to 2. That is option B is the correct here. Also you can take from this option, that is if you take substitute the alpha is equals to 1, alpha is equals to 2, alpha is equals to minus 1 and minus 2. Then you will get the correct answer here, the alpha is equals to 2. Okay, that is another way to solve this polynomial. Okay, therefore the option B is a correct here. Now next, if integral 0 to k 1 upon 2 plus 8x square is dx is equals to pi upon 16, then the value of k. This question asked in March 18 examination. First option A is 1 upon 2, B is 1 by 3, C is 1 by 4, D is 1 upon 5. Now we'll evaluate this integration and use the formula here. Integral 1 upon x square plus a square dx is equals to 1 upon a tan inverse of x upon a plus c. Now see this here, solution of this problem. First of all, from the denominator, take 8 as a common. Then in bracket, you will get here x square plus 1 upon 4 dx. Okay. And now take this 1 upon 8 outside from this integral sign. Therefore, 1 by 8 integral 0 to k 1 upon x square plus 1 by 4 means the square of 1 upon 2 bracket square dx. And its integration is 1 upon a. What is a here? 1 upon 2. Then multiply and reciprocal. It will become numerator. Okay. Or you can simplify here. Then you will get here 1 by 4. Here is 1 by 4. Tan inverse of x upon 1 upon 2. Multiply and reciprocal. It will become tan inverse of 2x, lower limit is 0, upper limit is k, and that's equals to pi upon 16. Now, upper limit minus lower limit. Upper limit is k, therefore x is replaced by k. 1 by 4 tan inverse of 2k minus tan inverse of 0 is equals to pi upon 16. Okay, therefore here, that is 1 by 4. So, divided here. If we take to the right hand side, it will become multiplied. Pi upon 16 into 4. 4 ones 1 and 4 fours are 16. Therefore, you will get here tan inverse of 2k is equals to pi by 4. Okay. And hence here, that is the 2k is equals to tan of pi by 4. So what is the value of tan of pi by 4 is 1. It means that 2k is equals to 1. And hence k is equals to 1 upon 2. And hence here, option A is correct. Okay. Now, next, if integral 0 to k 4x cube dx is equals to 16, then find the value of k. Okay. This question asked in February 20 examination. First option A is 1, B is 2, C is 3, and D is a 4. Now we evaluate this integration with the help of this formula. Okay. See this here. The integral of 4x cube is a x raised to 4 upon 4. This 4 get cancelled. Okay. Then you will get here x raised to 4. Lower limit is 0, upper limit is k, that's equals to 16. That is, if we substitute the limits, k raised to 4 minus 0 is equals to 16. Therefore, k is equals to taking the fourth root on both sides. Then you will get the value of k is 2. Okay, and hence option B is correct here. Now next, 7. If integral minus pi by 4 to plus pi by 4 of x cube into sine of x raised to 4 dx is equals to k, then what is the value of k? This question asked in March 24 examination. It's last year. First option A is 1, B is 2, C is 4, and D is 0. Now we'll evaluate this integration. Let f of x is equals to x cube sine of x raised to 4. But what is the f of minus x? That is x is replaced by minus x. That is minus x bracket cube sine of minus x raised to 4. Then you will get here minus x cube means what? Minus x bracket raised to 3 means what? Minus x cube. And this is the function. Okay. Therefore, the sine of minus x, we know the formula. Sine of minus x is minus sine x and raised to 4. Therefore, you will get here minus x cube sine of x raised to 4. That is the f of minus x is equals to minus f of x. Therefore, the given function is an odd function. And the help of the property of the definite integration, integral minus pi by 4 to plus pi by 4 x cube into sine of x raised to 4 dx is equals to 0. And hence here this is the property. Okay. Therefore, the option D is a correct here. Okay. Now next. Now we will discuss the question based on exercise 4.2, which asked in board examination. First question. Prove that integral a to b f of x dx is equals to integral a to b f of a plus b minus x dx, asked in 2006 and 2014 examination, and hence evaluate integral a to b f of x upon f of x plus f of a plus b minus x dx. Okay, this question asked in 2014 examination. Okay, now consider the first. We take the RHS of this first. RHS is equals to integral a to b f of a plus b minus x dx. Okay, I is equals to, now put here a plus b minus x is equals to t. Differentiate it. Derivative of minus x is minus dx. Derivative of t is dt, and it implies that dx is equals to minus dt. As we are changing the variable, limits will also change. When x is equals to a, substitute the value of here x is equals to a. Plus a minus a get cancelled. You will get here t is equals to b, and the next upper limit is b. Therefore, replace here x by b plus b minus b get cancelled. You will get here t is equals to a. Okay, and here for I is equals to integral a to b to a f of t minus dt, because here the lower limit is b, upper limit is a. Take the negative sign outside this integration, minus integral b to a f of t into dt, and again with the help of the property we will absorb the negative sign if we change upper limit and lower limit. Therefore, integral a to b f of t dt. Again the change in variable, function is same, limits are same, but we are changing the variable from t to x. With the help of these two properties, integral a to b f of x dx is equals to minus b to a f of x dx. This is the first property. Okay, and we have apply here, and integral a to b f of x dx is equals to, that is nothing but this is the LHS. For this, here we have they apply the property integral a to b f of x dx is equals to integral a to b f of t into dt. It's a change in variable property. Function is same, limits are also same. Okay, therefore this is the LHS, and we have proved this first part, that LHS is equals to RHS. Now we'll evaluate this integration. What is it integral? Integral a to b f of x upon f of x plus f of a plus b minus x dx. Okay, now see this here. This is the first one. That is we have to evaluate this integration. I is equals to integral a to b f of x upon f of x plus f of a plus b minus x dx. And with help of this formula, we will replace this f of x by f of upper limit plus lower limit minus variable. That is f of this f of x is replaced by f of a plus b minus x. Again, this f of x is replaced by f of a plus b minus x. Again, this f of a plus b minus x is replaced by a plus b, means what, upper limit plus lower limit minus this variable, which is a plus b minus x. Okay, and after evaluating and open this bracket, then you will get here to the denominator, that is the integral a to b, that is the numerator as it is, and to the denominator f of a plus b minus x. Minus a plus b get cancelled, then you will get here f of x. This is the second one and this is the first one. Now adding this 1 and 2, you will get here both of them have the same denominator. Therefore, you will get here f of x to the numerator plus f of a plus b minus x, and the denominator are the same. Okay, and therefore numerator denominator get cancelled. You will get the integral a to b 1 dx. What is the integral of dx is x. Upper limit is b, lower limit is a. Upper limit minus lower limit means what? B minus a. It means that the 2i is equals to b minus a, and hence I is equals to b minus a upon 2. And this is the answer. The value of this second one. You can see this. Next question. If integral 0 to h 1 upon 2 plus 8x square dx is equals to pi upon 16, then find the value of h. We have completed this type of question in multiple choice question. Okay. Now integral 0 to h 1 upon 2 plus 8x square dx is equals to pi upon 16. Okay. Now take 8 as a common, then you will get here 1 upon 18 bracket x square plus 1 by 4 dx is equals to pi upon 16. Take the constant outside this integral sign. Integral 0 to h 1 upon x square plus 1 by 4 means what? 1 upon 2 bracket square dx. What about the integral of this? Integral of 1 upon x square plus x square is equals into dx is equals to 1 upon a tan inverse of x upon a plus c. And hence you will get here 1 by 8, 1 upon 1 upon 2. Tan inverse of x upon a is 1 upon 2 integral 0 to h pi upon 16. And after simplification, you will get here 8 upon 2 means what? You will get here 4. X upon 1 upon 2 multiplied and reciprocal, you will get here tan inverse of 2x. Lower limit is 0, upper limit is h. That's equals to pi upon 16. Substitute the values. That is, x is replaced by h. Tan inverse of 2h minus tan inverse of 0 is equals to pi upon 16. Okay. Tan inverse of 2h minus tan inverse of 0 is 0 is equals to pi upon 16. And here is a 1 by 4 means what? 4 ones are 1 and 4 fours are 16. Therefore, you will get here pi by 4 is 4 and 4 get cancelled. Tan inverse of 2h is equals to pi by 4. Therefore, what is 2h is equals to tan of pi by 4. And what is the tan of pi by 4? That's equals to 1. Therefore, 2h is equals to 1, h is equals to 1 upon 2, and this is the answer. Now next, evaluate the integral 0 to pi by 2, 1 upon 1 plus cos x dx asked in March 15 examination. It's very easy. Now what is here formula? 1 plus cos of x, that is a 2 cos square x by 2. What is the angle? That's divided by 2. Take 1 upon 2 outside this integral sign. 0 to pi by 2 reciprocal, that is a 1 upon cos square x by 2 means what? Sec square x by 2. Now here we will apply the formula, that is integral sec square x dx is equals to tan of x plus c, and hence here the integral of sec square x by 2 is the tan of x by 2 upon derivative of this x by 2 means what? 1 up derivative of x is 1, that is 1 upon 2. Upper limit is pi by 2, lower limit is 0. Now upper limit minus lower limit, that is here this again 2 get cancelled, that is a tan of pi by 4 minus tan 0. Tan of pi by 4 is 1, tan of 0 is 0, and then hence you will get here I is equals to 1. Okay, and this is the answer. Now next, evaluate the integral 0 to pi x sin x upon 1 plus sin x dx. This question asked in March 15 examination. Let I is equals to 0 to pi x sin x upon 1 plus sin x, and here we will apply the property. What is that? Integral 0 to a f of x dx is equals to integral 0 to a f of a minus x dx. Means what? X is replaced by a minus x, and here we will replace here x pi minus x. Okay, now see this here, the pi minus x. What is the sine of pi minus x? Is a sine x. Sine of pi minus x is a sine x. Now separate this integration. Means what? That is a pi into sine x upon 1 plus sine x. This is the first part. Next is a minus x into sine x. This is the next part. Okay, after multiplying, this is sine x to pi. Take the first integration. Sine x into minus x. This is the second integral. Okay, now here the repetition of this I again here. See this here. That is pi 0 to integral 0 to pi sin x upon 1 plus sin x dx. This is the I is repeated here. Therefore, I written this is the minus I. Now shift this minus I to the left hand side. I plus I, it will become 2I. 2I is equals to pi integral 0 to pi sin x upon 1 plus sin x dx. Now evaluate this integration by multiplying numerator and the denominator 1 minus sin x. Okay, now sin x in bracket 1 minus sin x means what? Sin x minus sin square x upon 1 plus sin x into 1 minus sin x means what? 1 minus sin square x dx. But what is the 1 minus sin square x? It's a cos square x. Now separate this. Sin x upon cos square x minus sin square x upon cos square x dx. Okay, and the next pi integral 0 to pi sin x upon 1 cos x, then you will get a tan x, and 1 upon cos x means what? Sec x. Now here sin square x upon cos square x, that is tan square x. Okay, now we will apply the formula here. See this here, that is a tan x sin x sec x into tan x. What about here? Tan square x means what? In bracket sec square x minus 1, and if you open the bracket, then you will have here sec square x plus 1. Here we have applied the identities. Tan square x is equals to sec square x minus 1. Okay, and change the sign. Now next, see this here. The integral of sec x into tan x is a sec x, and the integral of sec square is a tan x. Okay, see this here. The integral of sec x tan x is a sec x, and the sec square is a tan x, and integral of 1 is a x. Upper limit is pi, lower limit is 0. Okay, substitute the values. Sec of pi minus tan of pi plus pi, lower limit is a 0. Okay, and hence here sec 0 minus tan 0 0. Sec of pi is a minus 1, tan of pi is a 0. Therefore here is a minus 1 plus pi. And what about here? The next minus sec of 0 is a 1, tan 0 is a 0, and here minus 1. Okay, and after here the minus 1 and minus 1, then you will get here pi minus 2. That is the 2I is equals to pi in bracket pi minus 2. Okay, and hence here I is equals to pi in bracket pi minus 2 upon 2, and this is the answer. That I is equals to pi. If you divide this to the pi and 2, then you will get here pi by 2 minus 1. Next, evaluate the integral 0 to pi x upon a cos square x plus b sin square x dx. This question asked in March 16 examination. I is equals to 0 to pi. Okay, therefore here we apply the property 0 to a f of x dx is equals to 0 to a f of a minus x. That is a variable is replaced by pi minus x. X is replaced by pi minus x. Then you will get here I is equals to 0 to pi minus x upon. What about the cos of pi minus x is the cos x. Sin of pi minus x is sin x, but they are the squares. Therefore, you will get here 0 to pi minus x upon a cos square x plus b sin square x dx. Now next, adding 1 and 2, both of them have the same denominator. Then you will get here 0 to pi x plus pi minus x upon a cos square x plus b sin square x. X get cancelled, therefore pi 0 to pi 1 upon a cos square x plus b sin square x dx. Okay, dividing numerator and the denominator by cos square x, then you will get here to the numerator, that is the 1 upon cos square x means what, sec square x, cos square get cancelled, you will get here a square plus b sin square x upon cos square, you will get here tan square x. Now here the substitute here. Here we will use the property integral 0 to 2a f of x dx is equals to 0 to a f of x plus f of 2a minus x. With the help of this property, you will get here, that is a pi g into integral 0 to pi by 2. In first bracket, the function is as it is, and in the second, x is replaced by pi minus x. Okay, therefore, so this here. Now as we replace the sec square x upon a square plus b square tan square x, both of them have the both these two terms are equal. Therefore, you will get here 2 pi 0 to pi by 2 sec square x upon a square plus b square tan square x. And here the I is equals to 2 get cancelled on both sides. Therefore, I is equals to 0 to pi sec square x upon a square plus b square tan square x dx. Now substitution. Put tan of x is equals to t. Therefore, sec square x dx is equals to dt. When x is equals to 0, t is equals to 0. If we substitute here, that is the lower limit is 0. When x is equals to pi by 2, t is equals to infinity. Okay, that is a 1 upon 0 means what, t is equals to infinity. And hence here I is equals to, our integral changes pi 0 to infinity dt upon a square plus b square into t square. Again take b square as a common. Therefore, you will get here pi upon b square 0 to infinity dt upon a upon b bracket square plus t square. And again the form is a integral 1 upon x square plus a square dx is equals to 1 upon a tan inverse of x upon a plus c. And you will get here pi upon b square 1 upon a upon b tan inverse of bt upon a. Okay, that is the tan inverse of t upon a upon b multiplied and reciprocal, you will get here bt upon a. And the lower limit is 0, upper limit is infinity. Now substitute here, that is here bb get cancelled, pi upon ab. Pi upon ab tan inverse of infinity minus tan inverse of 0. But what about the tan inverse of infinity is a pi by 2, tan inverse of 0 is a 0. And hence here you will get an answer pi into pi square upon ab into 2, that is a I is equals to pi square upon 2ab. Okay, finally this is the answer. Now next problem number 6. Prove that integral 0 to a f of x dx is equals to integral 0 to a f of a minus x dx. And hence evaluate integral 0 to pi by 2 sin x upon sin x plus cos x dx. This question asked in July 16 examination. Now first of all, we consider here the RHS of this proof. That okay. Consider RHS, that is a 0 to a f of a minus x dx. Okay. Now put here, that is a minus x is equals to t. Therefore, after differentiation, the derivative of a is 0, x is a minus dx, and derivative of t is a dt. Therefore, here dx is equals to minus dt. As we are changing the variable, therefore limits will also change. When x is equals to 0, our lower limit is x is equals to 0. Then substitute here x is equals to 0. Then you will get a t is equals to a minus 0. It means that t is equals to a. And when x is equals to a, that is when x is equals to a minus a, and that's equals to 0. That is a t is equals to 0. And therefore, our integral become, that is a I is equals to, our lower limit is a, upper limit is 0. And what about a minus x? A minus x is t, f of t. And the value of the dx is equals to minus dt. Take the minus sign outside this integrand sign, that is the minus a to 0 f of t dt. Okay, Now here the integral is written like this. Now we'll observe the negative sign when we change upper limit and lower limit. Therefore, you will get here integral 0 to a f of t dt. Okay, see this here with the help of this property. Integral a to b f of x dx is equals to minus b to a f of x dx. Okay, now next property, that is a change in variable. If the limits are same, function is same, then we can change the variable from t to x. Okay, this is the change in variable property. Therefore, this is nothing but the LHS. Okay, therefore the first part has been proved. Now next part, that is we want to evaluate integral 0 to pi by 2 sin x upon sin x plus cos x dx. Okay, now see this here. Let I is equals to 0 to pi by 2 sin x upon sin x plus cos x dx. Integral 0 to pi by 2. Now with the help of this property, 0 to a f of dx is equals to 0 to a f of a minus x dx. That is x is replaced by a minus x. Similarly here x is replaced by pi by 2 minus x. Sin of pi by 2 minus x is cos x. Sin of pi by 2 minus x is a cos x. And cos of pi by 2 minus x sin x dx. Okay. Therefore here we'll have to cut this f of x. Okay. Now next, adding 1 and 2. This is first and this is the second one. We will add here. That is I plus I. You will get here 2i. Integral 0 to pi by 2 sin x plus cos x upon sin x plus cos x dx. Okay, numerator and denominator both are equal. Therefore, their ratio is 1. Therefore, integral 0 to pi by 2 1 dx. What is the integral of 1? Is x 0 to pi by 2. Replace here x as a pi by 2. Upper limit is pi by 2. Lower limit is 0. 2i pi by 2 minus 0, and hence I is equals to pi by 4. 2 is multiplied here. If we take 2 the right hand side, it will multiply with the 2. Therefore, 2 into 2, 4. Therefore, I is equals to pi by 4. Okay, and this is the answer. Now, next question. Question number 7. Evaluate the integral minus a to plus a in root of a minus x upon a plus x dx. This question asked in March 17 examination. Now see this here, the integral. Multiplied numerator and the denominator of this right hand side by a minus x. That is a conjugate of denominator. Okay. Then after multiplication, you will get here a minus x into a minus x bracket square and root get cancelled. Therefore, to the numerator, you will get here a minus x, and to the denominator, a plus x into a minus x. Then you will get here a square minus x square. And hence here, integral minus a to plus a. Separate this integral. That is a upon in root of a square minus x square dx. Minus integral minus a to plus a x upon in root of a square minus x square dx. Okay. Now, a upon in root of a minus x square is a even function, and second x upon in root of a square minus x square is an odd function. Okay, therefore here the I is equals to 2 times, therefore the integral of this odd function is a 0 with the help of the property. Okay, that is the integral minus a to plus a f of x dx is equals to 2 times integral 0 to f of x dx if f of x is an even function and is equals to 0 if f of x is an odd function. Now this function is odd, therefore its integral is 0. And what about this? It is a 2 times integral 0 to a upon in root of a square minus x square dx. Okay. Now next, take 2 outside this integrand sign. Therefore 2a 0 to a. Okay, I will write here integral 0 to a 1 upon in root of a square minus x square dx. Now the integral of this is the sine inverse of x upon a, and the lower limit is 0, upper limit is a. Now with the help of this formula, okay, therefore substituting, you will get here 2a sine inverse of x is replaced by a upon a is 1, and x is replaced by 0. 0 upon a is a 0. Sine inverse of 0. Sine inverse of 1 minus sine inverse of 0. Sine inverse of 1 is a pi by 2 and sine inverse of 0 is a 0. Okay. Therefore, 2a in bracket pi by 2. Here 2 get cancelled. You will get here pi into a, and this is the answer. Okay. Now, next question. Question number 8. Prove that integral minus a to plus a f of x dx is equals to 2 times integral 0 to a f of x dx if f of x is an even function, and the integral minus a to plus a f of x dx is equals to 0 if f of x is an odd function. This example asked in October 15, July 17, 19, March 18 examination. Now we'll prove this first. Okay. Now here the LHS becomes, okay. What is the LHS? That is integral minus a to plus a f of x dx. We can write it like this. What is that? In between minus a and the plus a, that is a minus a less than or, and here the plus a. That is a 0 lies between minus a and plus a. Therefore, we can write here integral minus a to 0 f of x dx plus integral 0 to a f of x dx. This is the first one. Now here we will evaluate this first integral. That integral minus a to 0 f of x dx. For this substitution is important. Put x is equals to minus t. Therefore dx is equals to minus dt. And now we'll change the limit. When x is equals to minus a, t is equals to a. X is replaced by minus a. Then you will get here minus a is equals to minus t, means what, t is equals to a. When x is equals to 0, then t is equals to 0. Therefore, our integral becomes, that is a minus a to plus f of x dx is equals to integral a to 0, x is replaced by minus t and here minus dt. Take minus n outside from this integral sign. Therefore, minus integral a to 0 f of minus t dt. Now observe this negative sign by changing the limits of integration. Okay. Therefore, 0 will be to the lower limit and a will be to the upper limit with the help of the property. Okay. Now next, this is the property. Therefore, we have this that is equals to integral 0 to a f of minus x dx. Here we are again using the property of changing variable, because the functions are same and the limits are same, but we are changing only the variable. X is replaced by only t, and therefore this is the change in variable property. Okay. Integral a to b f of x dx is equals to integral a to b f of t into dt. Okay. Therefore the equation 1 becomes, this equation 1 becomes, means what, we will replace here, see this here, that is the integral minus a to plus f of x dx integral is equals to 0 to a. This is replaced by, this integral is replaced by 0 to a f of minus x dx plus integral 0 to a f of x dx. Okay. Now here we will take integral 0 to a in bracket f of minus x plus f of x dx, and this is the second one. Now we will discuss about this equation. See this here. Integral minus a to plus f of x dx is equals to integral f of minus x dx plus integral 0 to a f of x dx. Take integral sign outside. Then in bracket, that is integral 0 to a f of minus x plus f of x dx. First case, f of x is an even function, then f of minus x is equals to f of x. Therefore, this integral sign becomes, this f of minus x is replaced by f of x. Therefore, integral minus a to plus f of x dx is equals to integral 0 to a f of minus x is replaced by f of x plus this f of x plus f of x, that's equals to 2 times integral 0 to a f of x dx. This is the first one, when the function is even. Now when the function is odd, means what, f of minus x is equals to minus f of x, then you will have this equation second becomes, that integral minus a to plus f of x dx is equals to integral 0 to a f of minus x plus f of x. Now this f of minus x is replaced by minus f of x and second term is as it is. Now here minus f of x and plus f of x gets 0 and the integrand of the 0 is a 0 and hence we have proved this. Now next question. Evaluate integral 0 to pi by 2 sine square x dx. This question asked in March 19 examination. Okay. Now see this here with the help of the trigonometric formula. What is the sine square x? Sine square x means what? 1 minus cos of 2x upon 2. Okay, take this 1 upon 2 outside this integrand sign. That is 1 upon 2 integral 0 to pi by 2 in bracket 1 minus cos of 2x dx. Now here, what is the integral of cos of x? Integral of cos of x is the sin x. Therefore, 1 upon 2 integral of 1 is x. Integral of cos of 2x is the sin of 2x upon 2. Lower limit is 0, upper limit is pi by 2. Now substitute x, replace x as a first pi by 2, then 0. That is 1 upon 2 in bracket pi by 2 minus, if we replace here x by pi by 2, then 2 will get cancelled. But what is the sign of pi by sign of pi? Sign of pi is 0 and overall this will be 0 and it is written here. And what about the next? If we replace this as a x is replaced by 0, okay, then you will get here that is a sign of 0 is 0. Therefore, here 1 upon 2 in bracket. Or in first case, that is a x is replaced by first pi by 2, next 0. Therefore, in here first bracket is pi by 2 minus 0. And what about here? Minus 1 upon 2 is here. Next, here x is replaced by pi by 2. Then you will get here sign of pi. Next, x is by 0. Then you will get here sign of 0. Okay. Therefore, here pi by 2 minus 1 upon 2 sign of pi is 0. And overall, you will get here 0. That is 1 upon 2 into pi by 2. Then you will get here pi by 4. Okay. And therefore, this is the answer. Now, next question. Show that integral 0 to pi by 4 log of in bracket 1 plus tan of x dx is equals to pi by 8 log of 2. This example asked in March 19 and 22 examination. Now let I is equals to integral 0 to pi by 4 log of in bracket 1 plus tan of x dx is equals to integral 0 to pi by 2 pi by 4 log of. Now here x is replaced by, that is a pi by 4 minus x with the help of this property. What is this property? That is a 0 to a f of x dx is equals to 0 to a f of a minus x. X is replaced by a minus x. Similarly here x is replaced by pi by 4 minus x. Therefore, now next we will apply this formula. Tan of a minus b. Tan of a minus b is equals to tan of a minus tan b upon 1 plus tan of a into tan of b. Therefore, here integral 0 to pi by 4 log of 1 tan of pi by 4 minus tan x upon 1 plus tan of pi by 4 into tan x. Integral into dx. Integral 0 to pi by 4 log of 1 plus. What about the tan of pi by 4 is 1. 1 minus tan x upon 1 plus tan x into dx. And now simplify this. That is the 1 into 1 plus tan of x plus 1 minus tan of x. Now plus tan of x minus tan of x get cancelled. That is a log of 2 upon 1 plus tan x dx. Okay. And then you will get here integral 0 to pi by 2 log of 2 minus log of 1 plus tan x dx. Next integral 0 to pi by 4 log of 2 dx minus integral 0 to pi by 4 log of in bracket 1 plus tan x bracket complete into dx. This is nothing but again I is repeating here. Okay. Now see this here. I is repeated here. Therefore, our integral become I log of. Okay, see this here. Log of 2. But what about the integral of this is x. That is a log of 2 x. Lower limit is 0. Upper limit is pi by 4. I is repeated here. This is replaced by I here. Okay. Now take this minus I to the left hand side. It will become I plus I 2i. 2i is equals to log of 2. Upper limit pi by 4. Lower limit is 0. And therefore, that is I is equals to log of 2 into pi by 8. Okay. That is the 2 is multiplied here. If we take 2 the 2 that is to the right hand side, then it will become pi upon 4 into 2 means what? Pi by 8. Therefore here I is equals to pi by 8 into this log of 2, and hence I have completed this question. I is equals to pi by 8 into log of 2. Now next question. Evaluate the integral 0 to pi by 4 sec x raised to 4 dx. This question asked in March 22 examination. Now sec of x raised to 4 can be written as sec square x into sec square x. Next sec square x again written as 1 plus tan square x into bracket complete into sec square x dx. Now here the substitution, tan of x is equals to t, and as the substitution tan of x is equals to t, what about its derivative? Sec square x into dx is equals to dt. Now we'll change the limit. When the lower limit is 0, means what? Tan of 0 is equals to t, but the tan of 0 is 0. Therefore, when x is equals to 0, t is equals to 0. When x is equals to pi by 4, tan pi by 4 is 1. Therefore, t is equals to 1. Tan of pi by 4, that is 1. Therefore, t is equals to 1. Therefore, lower limit is 0, upper limit is 1 for the change in variable. Therefore, I is equals to 0 to 1 plus t square into dt. Simple integration. Integral of 1 is t and t square is a t cube upon 3. Okay. Lower limit is 0, upper limit is 1. Take the separate their values. Okay. 0 to 1 and then the t cube upon 3. 0 to 1. Lower limit is 0, upper limit is 1. Again upper limit minus lower limit. You will get here first 1 minus 0 and plus 1 by 3, 1 cube minus 0. And overall you will get here 1 plus 1 by 3. 1 plus 1 by 3 means what? 4 by 3. And hence I is equals to 4 upon 3. Okay. Now next. Evaluate the integral 0 to a 1 upon x in root of a square minus x square dx. This question asked in July 18 and 22 examination. Now we will evaluate it. For here, we take the substitution x is equals to a sin theta. What about the dx? Dx is equals to a cos theta into d theta. Derivative of sin theta is a cos theta. Now, as we are changing the variable, therefore we will change the limits also. When x is equals to 0, therefore replace here x as a 0. A sin theta is equals to 0. Therefore, sin theta is equals to 0. The value of theta is 0. Okay. Therefore, when x is equals to 0, then theta is equals to 0. Now, next upper limit, that is a. Therefore, a is equals to a sin theta. A get cancelled. Then you will get here sin theta is equals to 1. And therefore, theta is equals to here pi by 2. Okay. Now, our new integral become I is equals to 0. Lower limit is 0. Upper limit is pi by 2. Value of dx is a cos theta into d theta. And to the denominator, x is replaced by a sin theta plus in root of a square minus a square sin square theta. Take a square as a common. Root of a square is a. Okay. Therefore, integral 0 to pi by 2 a cos theta upon a sin theta plus a in root of 1 minus sin square theta d theta. Okay. Now, a get cancelled from numerator and the denominator. Therefore, our integral becomes 0 to pi by 2 cos theta upon sin theta plus in root of cos square theta, okay, into d theta. I will write here d theta here. Okay. Next, that is equals to integral 0 to pi by 2 cos theta upon sin theta plus cos theta into d theta. And this is the first one. Now next, integral 0 to pi by 2 cos of pi by 2 minus theta upon sin of pi by 2 minus theta plus cos of pi by 2 minus theta with the help of this property. Which is the property? 0 to a f of x dx can be written as 0 to a f of a minus x dx. Now what about the cos of pi by 2 minus theta is sin theta. Sin of pi by 2 minus theta is a cos theta. Cos of pi by 2 minus theta is a sin theta. Therefore, our integral become 0 to pi by 2 sin theta upon sin theta plus cos theta into d theta. This is second one. Now adding 1 and 2. Then you will get here To the left hand side, I plus I, and to the right hand side, see this here. Okay, we'll add this 1 and 2. After adding, you will get here 1 and 2. That is the 2I is equals to integral 0 to pi by 2 cos theta upon sin theta plus cos theta d theta. Next, plus 0 to pi by 2. Get here pi by 2 sin theta upon cos theta plus sin theta d theta. Both of them have the same denominator. Therefore, we will add it integral 0 to pi by 2 cos theta plus sin theta upon sin theta plus cos theta. Numerator denominator both are same. Therefore, that is a 2I is equals to integral 0 to pi by 2 d theta. Integral of d theta is theta. Upper limit is pi by 2, lower limit is 0. Therefore, pi by 2 minus theta. And hence, 2I is equals to pi by 2. Therefore, I is equals to 1 upon 2 into pi by 2. And hence, I is equals to pi by 4. And this is the answer. Now, next question. Evaluate the integral minus 3 to plus 3 x cube upon 9 minus x square dx. This question asked in July 22 examination. F of x is equals to x cube upon 9 minus x square. F of minus x is equals to in bracket minus x bracket cube upon 9 minus in bracket minus x bracket square. Here x is replaced by minus x. But what about here? Minus x bracket cube is a minus x cube upon 9 minus x square. And this is nothing but f of x. Means what? Minus f of x. Therefore, f of minus x is equals to minus f of x. Means what? The given function is odd function. And f of x is an odd function. Therefore, the integral minus 3 to plus 3 x cube upon 9 minus x square dx is equals to 0. Okay. With the help of this property, you can see this minus a to plus f of x dx is equals to 0 if f of x is an odd function. And hence the answer is 0. Now next, prove that integral 0 to 2a f of x dx is equals to 0 to a f of x dx plus 0 to a f of 2a minus x dx. This question asks number of times the board examination. Okay. Now consider first of all here RHS. That is integral 0 to a f of x dx plus 0 to a f of 2a minus x dx. Okay. Now here let I is equals to, we consider this RHS as I, 0 to a f of x dx plus 0 to a f of 2a minus x, I1 and I2 separately. Okay. Now consider I2. That I2 is equals to 0 to a f of 2a minus x. What is your substitution? Put 2a minus x is equals to t. Therefore, minus dx is equals to dt. Therefore, dx is equals to minus dt. When x is equals to 0, x is equals to 0, t is equals to 2a. When x is equals to a, x is equals to a, that is 2a minus a, then you will get here a. Therefore, t is equals to a. That is a lower limit is a 2a and the upper limit is a. Okay. See this here, the integral I2. Lower limit is 2a, upper limit is a, f of t minus in bracket minus dt. Take the minus sign outside this integrate sign. That is minus integral 2a to a f of t dt. Now we'll absorb this negative sign by changing the limits. That is lower limit to upper and upper to lower. Therefore, our integral become integral a to 2a f of t dt. Okay. Now again we will apply the change in variable property. This all equals to integral I2 is equals to integral a to 2a f of x dx. This is the I2. Therefore, I is equals to I1 plus I2 is equals to integral 0 to a f of x dx plus integral 0 to a f of 2a minus x dx. Okay. Therefore, this first integral is as it is, I1 is as it is. But what is the value of this I2? The value of I2 is integral 0 to 2a f of x dx. Okay. This is the first previous part. Therefore, I is equals to I1 plus I2. Okay. That is the integral 0 to a f of x dx plus a to 2a f of x dx. It means that is a lies between 0 to 2a, and in combined form it is written as 0 to 2a f of x dx, and that is equals to LHS with the help of this formula. What is that formula? Integral a to b f of x dx is equals to integral a to c f of x dx plus c to b. Here I will write here c to b f of x dx, where c lies between a and b. Here a lies between 0 and 2a, and hence our integral is written as 0 to 2a f of x dx, but this is nothing but LHS, and hence LHS is equals to RHS. Therefore integral 0 to 2a f of x dx is equals to integral 0 to a f of x dx plus 0 to a f of 2a minus x dx. Now next, evaluate the integral 0 to pi by 2 in root of 1 minus cos of 4x dx. This question asked in March 23 examination. Now what is the formula? That is 1 minus cos of a is equals to 2 sine square a by 2. Whatever the angle divided by 2. Here the angle is 4x. 4x upon 2. Then you will get here 2x. That is the in root of 2 sine square 2x dx. Okay. Next, take this root 2 outside this integral sign. That is root 2 into integral 0 to pi by 2 sine of 2x dx. But what about the integral of sine of 2x? Is a minus cos of 2x upon derivative of this 2x, which is 2. Lower limit is 0, upper limit is pi by 2. Therefore, that is a root 2 upon 2 cos of here 2x. Cos of 2x, that is x is replaced by pi by 2. 2 get cancelled. It means that you will get here cos of pi. Lower limit x is 0, therefore cos of 0. Therefore minus root 2 upon 2. Cos of pi is minus 1. Cos of 0 is 1. Minus 1 and minus 1 minus 2. Minus minus will become 2 get cancelled, and overall you will get here I is equals to root 2. Okay, and this is the answer. Now next question. Evaluate the integral pi by 6 to pi by 3 cos x dx. Now integral of cos x is a sin x. Lower limit is a pi by 6, upper limit is a pi by 3. Okay, integral of cos x is a sin x. Therefore, here replace here x by pi by 3 and pi by 6. Sine of pi by 3 is a root 3 upon 2. Sine of pi by 6 1 upon 2. And after simplification, you will get here I is equals to root 3 minus 1 upon 2. This is the answer. Now next, evaluate the integral 0 to pi by 2 cos cube x dx. This question asked in July 23 examination. Now what is the value of, that is a cos cube theta. Cos cube theta means what? Cos of 3 theta plus 3 cos theta upon 4. That is a 3 cos theta plus cos of 3x upon 4, using with the help of this formula. Now here, that is a separate this integral. That is a 3 by 4 cos x. Okay, that is the 3 by 4 integral 0 to pi by 2 cos x dx. Next is 1 by 4 integral 0 to pi by 2 cos of 3x dx. What about the integral of this cos of x dx? That is the integral of cos of x dx is a sin of x. Lower limit is 0, upper limit is pi by 2. Next is 1 by 4 sin of 3x upon 3. Lower limit is 0, upper limit is a pi by 2. And after substituting upper limit minus lower limit, then you will get here 3 by 4 sin of pi by 2 minus sin 0 plus 1 by 4 into 3, 1 by 12 sin of 3 pi by 2 minus sin 0. And hence you will have 3 by 4 sin of pi by 2 is 1 minus 0, 1 upon 12. What about the sin of 3 pi by 2? Sin of 3 pi by 2 is minus 1, sin 0 is 0. Therefore, you will get here 3 by 4 minus 1 by 12. After simplifying, you will get here. That is, make here the denominator as 12. Therefore, multiply numerator denominator by 3. 3 into 3, 9 upon 12 minus 1 upon 12. 9 minus 1 upon 12 means what? 8 upon 12. And after simplification, you will get here, that is a 2 upon 3. That is a 4 2s are 8 and 4 3s are 12. Therefore, I is equals to 2 upon 3. Okay. Now, next, question number 18. Evaluate the integral 0 to pi by 2 cos square x into dx. This question asked in February 20 and March 24 examination. Now here use the formula cos square x means what? 1 plus cos of 2x upon 2. Take 1 upon 2 outside this integral sign. That is 1 upon 2, 0 to pi by 2 in bracket 1 plus cos of 2x dx. Now integral of cos of x is a sin x. Therefore 1 by 2 integral of 1 is x. Cos of 2x is a sin of 2x upon 2. 0 to pi by 2. Upper limit minus lower limit. Now in first case replace this x by 0. Means what? Pi by 2 then 0. That is pi by 2 minus 0. And next this 1 upon 2. And here replace this x by pi by 2 and the 0. Means what? 1 upon 2. If you replace here x by pi by 2, 2 get cancelled, sin of pi. Then replace x by 0. Then you will get here sin 0. Okay. And next 1 upon 2, pi by 2, sin of pi is 0. Okay. That is 1 upon 2 into 0 is 0. 1 upon 2 into pi by 2. Then you will get here pi by 4. Therefore, I is equals to pi by 4. Okay. And next, question number 19. Prove that integral 0 to 2a f of x dx is equals to integral 0 to a f of x dx plus integral 0 to a f of 2a minus x dx. We have proved this. Okay. Now we'll prove this only this integral. That is a 0 to pi sin x dx is equals to 2 times 0 to pi by 2 sin x dx. This question asked in March 24 examination. Now with the help of this property, that is 0 to pi sin x dx is equals to 0 to here pi by 2 sin of x dx. And what about here? Integral 0 to a sin of. What is here? 2a. 2a is nothing but pi. Sin of pi minus x. Both of them have the same lower limit and the upper limit. Similar. Sin of pi minus x is a sin x. Okay. Therefore, 0 to pi by 2 sin x dx plus 0 to pi by 2 sin x dx is nothing but 2 times 0 to pi by 2 sin x dx, and hence integral 0 to pi sin x dx is equals to 2 times 0 to pi by 2 sin x dx, and hence I have completed this problem. And in this way, we have completed all problems which asked in previous year board examination. Okay. And I will give the link of the videos, that is a uh, exercise 4.2 and the miscellaneous exercise in the description box. You must watch that two videos. Now we will see in the next video. Till then, goodbye.